Hello students, today we're going to continue showing things are going to be congruent. However, we're not just going to show that two triangles are congruent, we're going to be focusing on the pieces of those triangles. So thinking back to what we've done already for our 5 triangle congruences, we've done 5 of them to show that two triangles themselves are congruent. So we have side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. And again, the purpose of these was just to show that two triangles were congruent given limited amount of information. So we didn't have to go through and show that all of the things were going to be congruent. So again, this information was just to show that two triangles were actually congruent. So what we have to think about is going back to our very first section of this unit, and we talked about showing that when two things are congruent, we went through and listed out their corresponding parts, meaning the angles that were congruent to each other and the side lengths that were congruent to each other. And so by definition, when we have two congruent triangles, they all have congruent corresponding parts. And so what this lesson is going to do is kind of combining that idea of showing these two triangles are congruent and then looking at a pair of sides or a pair of angles that weren't listed as being congruent and following it up by saying these guys have to be congruent because the two triangles are going to be the same. So as usual, we've been doing a lot of proofs, so let's go ahead and show how this works by using proofs. So in this example here, we're trying to show that angle S is congruent to angle U. And so you can see what we're trying to prove is different now. Instead of trying to show that the two triangles are congruent, we're trying to show pieces are congruent. And that is not listed in the actual diagram. So I don't know right now that angle S is congruent to angle U. So our first step is do like we've done in the last couple of units, which is to show the two triangles are congruent. So let's list what we know. Okay, angle S is congruent to angle UT, that's given because it's marked in the diagram. ST is congruent to UV, is also marked in the diagram, so that's a given. So those are the only two things that are given in our diagram because those are what's marked. And so the last thing is kind of what we saw was very common, which is this shared piece in between. And we talked about that before. TV is congruent to VT. Those two things are actually pieces of different triangles, and they're congruent by the reflexive property of congruence. So even though they're the same line in the diagram, they're part of two different triangles. And so what I see here is that I've shown that three sides are going to be the same. So I've shown the two triangles are congruent by side, side, side. So in the past, this is where we would normally stop. Now we're going to take this one step further based upon what we just talked about. And so we're only really adding on one extra step, and that's what we're trying to prove. Angle S is congruent to angle U. And why is that the case? Because corresponding parts of congruent triangles are congruent. So that's what we just talked about. And you might want to get that written down. Corresponding parts of congruent triangles are congruent is now one of the other reasonings that we can use. However, everybody finds that that's too long to write out, so what we do is, and anytime you do problems in the class or on the test or anything like that, you are allowed to use a abbreviation for that, and remember it's corresponding parts, so CP of congruent triangles, so CT are congruent, C. Okay, so we can abbreviate now in our proofs as Cpctc, so that's what you're going to be seeing from now on. So let's take a look at another example here. Now we're going to find the length of that ravine that's over there, or length of AB. And the first thing we need to do is determine whether or not those triangles are congruent. And so we're going back to one of our 5 congruences. And so what I notice is that A to the center here is 10, and this is also 10. So I know I have a side. The second side of the two here that are 15 miles. And then the third thing we have in common here is this angle in the middle. Okay, those are vertical angles. So we can go ahead and say that these two triangles are congruent. And specifically, we're going to say that they're congruent by side, angle, side. And so now to take it one step further, we're going to say that the two side lengths, the one that has the 18 measures here and the length of AB, are going to be congruent. Since the two triangles are congruent, those two pieces are congruent by Cpctc. So therefore, the length of AB has to be 18 miles. All right, one more proof for us to do, I believe. Given that YW bisects XZ, and then XY is congruent to YZ. So let's go ahead and start by running down our two givens here. And then we want to kind of take a look at what else can I figure out. Well, looking at my diagram, I see that these guys are sharing a side, so I'm going to go ahead and bring that into the diagram. So YW is congruent to YW, and again, that's the reflexive property of congruence. And so what else can I tell? Well, from my given, I'm telling you that YW is bisecting this length of XZ. Well, bisecting means it's cutting it exactly into two congruent pieces. So I know that XW is going to be congruent to ZW, and that's the definition of bisector. And so I've already know that this piece is congruent to this piece. I've shown they have the same side, and I've shown that that's the same, and so I can say the two triangles are congruent by side, side, side. And so the actual thing I want to prove, though, is not that the triangles are congruent, but the angles XYW, so this angle here, is congruent to ZYW, which is this angle here. And so those guys, we're going to take it, like I said, one step further, say that they're congruent, and our reasoning, abbreviated, is the Cpctc. So you should see that everything is the same up until that very last step. So there are a couple more examples. I was wrong. So here's our next one. If I were you, I'd try to pause the video, give yourself a try to see if you can come up with some of these things, and then come back and check your answers. Okay, so this one is very similar to the one that we just did. I'm telling you that PR bisecting the angle QPS and angle QRS. So it's very similar to the last one. The difference is instead of being a segment bisector, it's an angle bisector. But let's go ahead and start by writing down what we know, which is that these two things are being bisected, so that's a given. So let's go ahead and see the obvious thing that we have from the diagram, which is that shared side. Anytime we have that shared side, we're probably going to want to use it. So segment PR is congruent to segment PR. That's the reflexive property of congruence. So now let's go back to the fact that two angles are being bisected. And so when angles are being bisected, they're getting cut into two congruent pieces. Okay, so that means this angle here is congruent to this angle, and we also have this angle being congruent to this angle. So like in the previous one, the side was being bisected. In this case, two angles are, and that's given to us. So I'm going to list off those two angles, and that's the definition of bisector. And again, I'm going to do the same thing for the other set of angles there. And so do I have enough information? Well, I have a side and I have two angles. The next thing is to figure out, well, what order does it go in? And I can see from the diagram here, it would be angle, side, angle. So the two triangles are congruent by angle, side, angle. Well, if the triangles are congruent, then their pieces are congruent. So I know that PQ has to be congruent to QPS, and that's by Cpctc. Okay, that's all for our proofs. We're going to go and do one more problem. It's not going to be a formal proof, even though it says prove that the angles are going to be congruent. We're not going to go through and do a formal proof. So this is something that you need to be able to know how to do. We saw problems like this when we did side, side, side in the past. So we're going to plot those points, D, E, F, and G, H, I, and create two triangles from that. And then what we're going to want to do from there is find the length of each side and show that they are congruent. Okay? So once you plot those points, this is what it should look like. We have DEF on the bottom left and GHI on the top right. Please don't go through and assume. When I ask you to do these kinds of problems, I would expect you to go through and actually find the side lengths. So that's what I'm going to do in my next step. So I'm going to go ahead and switch the slide. So just to kind of recall, the distance formula is the square root, and then you subtract the x's, square them, subtract the y's and square them, and add the two numbers together, take the square root. And so this is just a very quick version of what we would actually be doing. We would go through and substitute the values in for D, E, F, G, H, and go through and actually find out what their values are. So you can see here, the length of DE is 2 square root of 5, or if you have square root of 20, that's fine. EF is the square root of 5, and GH is 2 square root of 5, or square root of 20. It doesn't really matter. You can also go through and get the decimals if you'd like. DF is the square root of 13, GI is the square root of 13, and GHI is the square root of 5. So if you had taken a look, so if you kind of take a look back at those original triangles that you've drawn, you can see that DE and GH are the same length, EF and HI are the same length, and GI and DF are the same length. So by side, 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 the two triangles are congruent, and then by Cpctc, those two angles that we wanted to show were congruent are actually congruent. Okay, very last thing we want to talk about is that we can use congruent triangles to find things that are kind of impossible for us to do. For example, here you want to find the distance across the lake. It's very similar to the ravine problem that we just showed. Explain how we're going to find the distance from point N to point P, knowing the information given in the diagram. Okay, so our goal here is to figure out, well, what's this length here? And we know all this information that's given here. These two are going to be the same length. Okay, so let's take a look at it like the triangles that you're used to seeing. This is the information that we know. So what's nice is that if we were to draw a triangle that looks just like that, we would be able to show that they're congruent by angle, side, angle. Okay, remember we have this unmarked one, which are our vertical angles there. And then if we can find the length of LK, then that will give us the length for NP. Alright, that's it for this video. Go ahead and hit the pause button. Remember, the big idea behind this is you're still showing the triangles are congruent. We're just taking it one step further, and we're showing that the individual pieces that are not marked, such as in this problem LK and NP, those guys are congruent by the Cpctc.